In this course, we are going to study the electromagnetic interaction, how two objects interact when the electromagnetic interaction is involved. Two objects interact only with four different ways of interactions, and the different ways of interaction are related with the four different forces that are in the universe. And what are these forces? The first forces is the gravitational force. The gravitational force makes one object to act in another object if there is an attribute of any object, every object, that is the mass. If you have mass, you have the interaction between them, and the gravitational interaction is an attractive interaction. So there are only four different forces that can make possible that one object can interact in another object. The one is the gravitational force, the other one is the weak nuclear force. These forces are acting on a distance, very, very small distance, the size of the nucleus, 10 to the minus 15 meters. And there are two nuclear forces, the weak nuclear forces and the strong nuclear forces. These nuclear forces are responsible for keeping the nucleus stable. The strong nuclear forces maintain the protons despite the repulsion for two equal charges. The strong nuclear force maintain the nucleus stable, and the weak nuclear force is responsible for processes like radioactivity. About gravitational forces, we are going to review gravitational forces because maybe the best way to link the new knowledge is to link it with the old knowledge. The old knowledge that we have for gravitational forces is like this. You have a body and you give an attribute to the body, the mass. This is the attribute. When you give the attribute, the mass, to the body creates a gravitational field surrounded the objects, and this force, the gravitational field that is acting on a mass m, little m, the force is the force acting on little m due to the source, to the capital M, is the following force. We know from the last course is proportional to the product of the mass, is inverse proportional to the square of the distance, so we create a vector position from the source to the point of observation. We call this the vector r, and the magnitude of the vector r is the distance between the source and the little m. So the force is proportional to the distance squared, and the force is going in the direction of the unitary vector u sub r that goes from the source to the little m. So it's proportional to u sub r, but the force is negative in the sense that the force acting on m is going in the opposite direction of u sub r. So this is the force acting on m due to capital M. So this is the expression for the gravitational force of two mass. So the idea is in gravitational force we give an attribute. The attribute is the mass. When we give an attribute to a body, the body changes in a way that now any other particle that is surrounding him, it will be affected by a force, and the force is always attractive. So M and M are always positive, and the force are always attractive forces. So now we are going to study to link this idea with electrical force. What happened with the electrical force now? Now with the electrical force we have an attribute that the objects have, and the attribute is the charge. The charge, we give this attribute to the body, and when another body with another charge q, little q, is near the surrounding of the object, there is a force acting on q, little q, due to the source. This is the source, and this is the acting on. And the force is now K proportional to the product of the charges, Q by Q, Q multiplied by Q, the distance square of the separation, that they are separated by the distance R. This is the vector R, and the vector R have a magnitude that we call the distance D, magnitude of R, the distance that separate, and have a direction. The direction of the force is from the source to the point of observation. So this is the direction, u sub R. R by u sub R, this is the vector R. The vector R have a magnitude of R, and the direction of u sub R, and the direction of u sub R is pointing in this direction, from the source to the point of observation. So I need to write here a vector u sub R. And now this is the force. As you see, there is no a minus sign or a y, because what will happen is that if Q is positive and Q is positive, the force will be in the direction of u sub R, will be something positive in the direction of u sub R. So in this direction, u sub R. So if Q is positive and capital Q is positive, the source is positive, the force will be in this direction. Force acting on Q. Then we can say that like charges that have the same attribute, both of them are positive, they have repulsions, is positive forces. If Q is negative and Q is negative, the force acting on Q due to Q will be something proportional to the product of the charge, but the product will be negative by negative will be positive. So again, the force acting on Q due to the capital Q will be plus u sub R, plus something in the direction u sub R. And again, I will find the force in this direction. But then again we find when the two charges have the same attribute, both of them are negative, the force is repulsive. It's going, the force acting on little q due to q is going to the right, is going in the direction of u sub R. What happens if q is negative and q is positive? So now the force will be proportional, K, to the product of the charge, but the product of the charge will be negative in the direction of u sub R. So the force on Q due to Q, in this case, will go in this direction. If Q and Q are different signs. So that means that charges that have different attributes, they are attractive. So the force, this is the source, Q, capital Q, this is the point of observation where the small q is here, This is the vector r, the vector r from the source. This is the vector u sub r, and in this case, the force on q, little q, is not going to the right, is being attractive in the going in the minus sign. So it's going to be like this. So that it says that when the chart have different attributes, the force acting on q, on little q, is an attractive force. You can do the same kind of reason of arguments using little q as the source and capital Q as the point of observation. If you do this, you will have to consider that this is the little q, this is the capital Q. Now, if you consider that Q is the source, the vector position is this vector position R. And the u sub r is this one. And you can find the force acting on Q due to little q. It will be k by q multiplied by q divided by the magnitude of r squared, the magnitude of this vector r, this is the vector r now, by u sub r. Who is the vector u sub r? Is this vector, the unitary vector. So pay attention, the vector r is the magnitude of r, 5 meters, in the direction of u sub r. What it says, this equation, is that u sub r, the unitary vector in the direction of r, is simple the vector r divided by the magnitude of r. The magnitude of r. And this is the vector u sub r. And we finish here with one example. And the example is like this. Imagine you have a char little q. Little q, what's the value of little q? Little q. And you have another chart of magnitude of charge, capital Q. And I want to find the force acting on Q, little q, due to capital Q, acting on. Find this force. It will be proportional to Q divided by the distance square. I want you to find the distance square in this case. This is 1 meter. This is 5 meters. So the distance square, this is 4 meters. This is 3 meters. The distance square is the distance of this vector. The vector r is this vector from the source to the point of observation Q, and the force, the distance r, is easy to find. This is 1 and this is 4. So it's the distance force. So I need the vector u sub r. Find u sub r and find F on Q due to Q equal to, well, you know, K, Q, Q. The distance square is 4 squared plus 1 squared. And I want you to find u sub r. The vector u sub r will be this vector. This is what I want you to find. And once that you find the force, I want to find Fx and Fy. So what exactly I want to find? The force F due Q, acting on little q, due to Q in the direction of X. And I want to find the vector, the component of the vector F, the component of the vector F acting on Q due to Q in the y direction. Equal and equal. If you want, you can put K equal 9 by 10 to the 9 newtons meter square divide by Coulomb squared, and you can put Q equal 1 Coulomb and capital Q equal minus 1 Coulomb. Find the force. Good luck.